This is question 3. We're given f of x is equal to 2x cubed minus 5x squared plus ax plus 18, where a is the constant. Given that x minus 3 is a factor of f of x, in part A for 2 marks, we need to show that a is equal to minus 9. If x minus 3 is a factor, we can say f of 3 is equal to 0. Setting the left hand side to 0, 0 will be equal to 2 lots of 3 to the power 3, which is 27, minus 5 lots of 3 to the power of 2, which is going to give me 9, plus a lots of 3 plus the 18. If we tidy this up, we're going to have 0 is equal to 54 minus 45 plus 3a plus the 18. 54 minus 45 plus 18 will give me 27, so we've got 27 plus 3a. Therefore, we can state at this stage that a is equal to minus 9. You can, of course, go ahead and solve that equation, but the workings here should be sufficient for the 2 marks. In part B, we're asked to factorise f of x completely. The question carries 4 marks. At this stage, we can either equate coefficients or we can use polynomial long division. I'm going to equate coefficients and set up an identity. X minus 3, which is the linear factor, multiplied by a quadratic factor of ax squared plus bx plus c will now be equal to the original function, which is 2x cubed minus 5x squared. We now have plus ax, we know is minus 9x plus the 18. So at this stage I'm going to equate coefficients. If I look now at the terms in x cubed, on the left hand side we're going to have ax cubed, on the right hand side we're going to have 2x cubed. Therefore we can state that a will be equal to 2. I'm now going to look at the constant. If we consider the constant on the left hand side, we'll have minus 3c, and the constant on the right hand side is 18. At this stage here we can say now that c is equal to minus 6. I'm now going to look at terms in x to find b. So terms in x, on the left hand side we're going to have cx minus 3bx, and then on the right hand side we're going to have minus 9. So we can say that c minus 3b is equal to minus 9. We know that c is minus 6, so minus 6 minus 3b is equal to minus 9. Adding 6 and dividing by minus 3, we can see now that b will be equal to 1. At this stage I can put this back together and I can write that the f of x is now the product of a linear factor, which is x minus 3, multiplied by a quadratic factor. I'll then look to factor the quadratic into 2 linear factors. So we've got 2x squared, we've got plus x minus 6. So let's go ahead now and see if we can factor this. That looks like it's going to factor, so we can say the f of x is x minus 3 multiplied by 2x minus 3, and then we're going to have now x plus 2. So I've gone ahead and factored now the f of x, and there are lots of different ways that you could deal with this. It says then now, given that g of y is equal to 2 lots of 3 to the 3y minus 5 lots of 3 to the 2y minus 9 lots of 3 to the y plus 18, in part C, find the values of y that satisfy g of y equals 0, giving your answers to 2 decimal places where appropriate. If we look at f of x and g of y, these are similar. The only difference is that we have x here and 3 to the y. So what I'm going to do is solve f of x is equal to 0. If we solve f of x is equal to 0, going back to our 3 linear factors, we can say that x would be equal to 3, x would be equal to 3 over 2, or x would be equal to minus 2. Let's now consider making a substitution. We can see now that x can be equal to 3 to the y. So what I'm going to say is let x be equal to 3 to the y. This will allow me to solve g of y is equal to 0. So what we can state at this stage now is therefore 3 to the y is equal to 3. 3 to the y is equal to 3 over 2, or 3 to the y is equal to minus 2. Now, there are no real solutions for this one right here, so we can state that 3 to the y can never be equal to minus 2. This one is fairly straightforward. If we got 3 to the y is equal to 3, we can say y is equal to 1. That's fairly straightforward. Let's now look at this one. For this one, we need to use logs. So what I'm going to write now is log of 3 to the y is equal to log of 3 over 2. I've simply now at this stage taken logs, base 10 of both sides of the equation. Using the power law, y log 3 is equal to log of 3 over 2. I'm now going to solve for y, so y will be equal to log of 3 over 2 over log of 3. So all I'm going to work this out on the calculator is just give now an answer correct to 2 decimal places. So let's go ahead and do that. We can look now at log of 3 over 2, or 1.5, divided by now log of 3. So if I do that, I'm going to end up with 0.369 and so on and so forth. I need to give this to 2 decimal places, so to 2 decimal places 0.37. So we can say y is equal to 0.37, and that's 2 dp. So our final 2 answers, we have y is equal to 0.37 or y is equal to 1. With this question, there are lots of different ways around it. This is just one particular approach. And in total, there are 9 marks for the question.